This is Module 2, Lecture 2, Theory Part. In this lecture, we're going to cover what is feature scaling, and there are different types of feature scaling. We're going to talk about that. But first of all, we need to focus on why do we need even the feature scaling. So the feature scaling is mainly the technique used to standardize the range of variables or features of data. Remember, in our previous lecture, I mentioned that in our data set, each column represents variable or features. Okay, so we can call it variable or even feature. In our previous lecture data set, we had age, gender, household income, and consumers' willingness to pay information. So those each column are the variables. Now most of the time in our data set, we have different types of variables. Okay, and we will get a different types of variables, and the range of variables may differ a lot. Okay, so if you have a data set, you will see different types of variables, and the ranges, all those ranges of those variables are also different. Now, when you have different types of variables and also the ranges of variables are different, if you use that data without pre-processing, without scaling, if you use this data to analyze, then there is a high probability that you will get biased estimation. So using the original scale may put more weight on the variables with large range. Okay, so when you use that original scale to analyze the data, there is a high probability that your estimation put more weight on the large range, a variable with large range, rather than a variable with small range. So you will get a biased estimation. In plain English, it means that your data analysis is not correct. Now let's take an example to understand what's going on here. Okay, so it will be much easier to understand this kind of problem if we have an example. Suppose we have a data set and it contains three variables. One is age of the participant or the consumer, income of the consumer, so we have age, which is in terms of years, right? How many years old you are. And then we have the income, and income we measure in terms of thousands of US dollar. And then we have the gender, whether it's a male or female. And the previous lecture we have seen how to convert this kind of variable as dummy variable, which takes only two values, 0 or 1. So my gender is a dummy variable which takes 0 and 1. So we have age of consumers, income of consumers, and their gender. Okay, three information. So we have three variables, three column in our data set. Now notice that the variables are not on the same scale. Okay, so we have three variables and they are not on the same scale because we measure age in years and generally it's a two-digit number, right? Now the gender, since it's a dummy variable, it takes value either 0 or 1, right? So it's a one-digit number and it's only 0 or 1. And now consider the another variable we have, that is income, and which is in terms of $1,000. Okay, so it is at least 4-digit numbers minimum. So it's generally 4 to 6 or 7 or 8-digit numbers you have as income. Now you see that although we have three variables, they are not on the same scale, and we have the smallest range is the gender one, because it's a 1-digit number and it ranges from 0 to 1, smallest range. The largest range is the income. It could be ranges from 1000 to, so it can be from 4-digit to 6, 7 or 8-digit number. So now if I don't do anything and if I use this data set to analyze the data, any model, statistical model, we are gonna use, those model will be biased toward the high range values. And which one is the high range value? Income, right? It is the largest range in our data set. So if I estimate anything, the result will be more biased towards the income variable rather than age and the gender. So any results coming from my analysis is not correct. So any data analysis may result in biased estimation when the variables are not on the same scale. Now, is there any solution? Yes, there are different ways to solve this problem. One way to solve this problem is data normalization. Okay? And we're going to learn how to normalize the data. First of all, what is normalization? So, normalization is a scaling technique in which values are shifted and descaled so that they end up ranging between 0 and 1. So we're going to use the technique to convert all the values under each column, and we're going to rescale those values between 0 and 1. Okay? And there are different types of normalization methods available. However, in this course, we're going to focus only one, and that is the min-max scaling technique. Now, the main objective of min-max scaling technique is to rescale values in a variable, means that all the values available under each column in our Excel file, we would like to rescale all those values in such a way that it ranges between 0 and 1. That's it. Whether it's the income data or age data or the gender, we're gonna rescale in such a way that values will be between 0 or 1. Okay? So it can be 0.5, 0.6, 0.75, like this. So all the values between 0 and 1. Now what's the formula to do that? The formula is very simple. So X is my normalized data. So I can pick any cell from the Excel file. Under any column I can pick any data. Okay, and we're gonna rescale, we're gonna normalize that data. How? We need that data, whichever data I'm picking, X, minus the minimum value of that column. Okay, so any column you pick, say income column, okay, income of the consumers. So under this column we need to find out first the minimum value of that column, that is my X min. We also need to find out the max value of that column, that is my X max, and X is the data or cell under that column which I want to normalize. So x is my data minus the minimum value of that column, okay? And we are going to divide this whole difference by the max value of that column minus the minimum value of that column. So this is my formula to rescale or normalize our data between 0 and 1 value.